Hello everyone, welcome to episode 1A of Physics O-Level. In the first episode, we are going to discuss about the fundamentals of physics. So, for topic 1, which is the fundamentals of physics, it is going to be divided into two different subtopics. The first one would be physical quantity, and measurements, which is today's episode, while the second subtopic will be about scalar, vector, and vector diagrams. And for today's episode, we are going to be discussing about this one, physical quantity and measurements. So, let's start. Physical quantity and measurements. Let's discuss about physical quantity first. What is physical quantity? What's physical quantity? Physical quantity is a quantity that can be measured. So, this quantity must have two different things. It must have a magnitude, and it also must have a unit. Both of these things are the essentials to be a physical quantity. If there is no magnitude, then it is not a physical quantity. If it has no unit, then it is not a physical quantity. It must have both of them. So, what are the examples of physical quantity? I think we have all heard about this before, which are the base SI units. Right, the base SI units. Some of the examples of this are, for length, it will be meter, or we use the symbol m, small m. For mass, it will be kilograms. Time, it will be second. Current, electric current, it will be ampere. Temperature, it will be Kelvin. And there's also two more, which is amount of substance, or mole, and light intensity, which is candela, but it is not really important. It is not really important in the physics syllabus for O-level. For base SI units, for physical quantity, we also have to learn about the multiples and the submultiples. What are multiples and submultiples? Some example of multiples could be 10 to the power of 12, or we call this tera with the symbol large T. There's also giga with the capital G. 10 to the power of 6 would be mega with the capital M, and 10 to the power of 3 would be kilo with the small k. Submultiples, however, are the opposite of multiples. While multiples are bigger number, submultiples are lower than 10 to the power of 0. An example of this is 10 to the power of minus 1, which would be deci. Then 10 to the power of minus 2 would be centi. 10 to the power of minus 3, milli. Then 10 to the power of minus 6 would be micro. And 10 to the power of minus 9 will be nano. On to the second topic of today's episode, which is about measurements. Alright, measurements. The first fundamental that we have to look in is about measuring length. As we learned just not very while ago, length, the SI unit for length is meter. So how can we measure meter, right? Meters. How can we measure this? We can either use A meter rule, B, a measuring tape, or C, vernier calipers. But in this syllabus, in the newest syllabus, it is now called digital caliper. And D, digital micrometer. This one's a bit long. Screw gauge. Yeah. And for all of these 4 instruments, there are 2 things that we have to memorize or know. The first one is the precision and the range of the things, right? Let's make a table for this. Okay, for the meter rule, the precision of the meter rule would be 0.1 centimeter, and this would also be the same for the measuring tape. However, the range of the meter rule would be like an ordinary meter rule, for example. However, the range of the meter rule would be 0 to 100 centimeters, while the measuring tape could vary. And then for the digital calipers or the vernier calipers, its precision is 0.001 centimeter. The range could also vary. For the digital micrometer screw gauge, its precision is 0.0001 centimeter. Its range could also vary. Yeah. So for range, you would only need to memorize meter rule, while for the precision, you would need to know for all the instruments. It is also worth mentioning about measuring length that you have to pay attention to the parallax error. It's also something in physics that you must know. In order to avoid the parallax error, your eyes must be positioned such that the line of sight is perpendicular to the ruler. So, basically, when eyes aren't perpendicularly positioned to the ruler. An example of this is, for instance, this is your ruler. And then this is the ball, right? But when you look at it, you would instead see this as the number. Instead, what you have to do is you have to look from up here, such that you can see that the ball is here instead of here. Yes. So that is basically parallax error. The second fundamental about measuring would be measuring time. As we also learned not very while ago, the SI unit, the base SI unit for time would be seconds. So there are two ways you can measure time. One, you can use an analog stopwatch or digital stopwatch. Or B, you can also use a pendulum. Keep in mind that both of these things, when you use both of these things to measure something, you also have to take into account the human reaction time. So human reaction time is usually about 0.3 to 0.5 seconds. So when you measure an experiment using the stopwatch or the pendulum, you may have to minus off a bit of time for that human reaction time. For the pendulum, how does the pendulum work? Imagine this is a pendulum, right? If there is a ball suspended with this string over here, and it is then swung to A, B, C, you would have to count the number of oscillations. And when you count the number of oscillations, you can then work out to find the period. The period is the time needed to complete one oscillation. So what is one oscillation? So one oscillation, if we start from A, then it will go to B, then it will go to C. That is half an oscillation. A whole oscillation would be from A to B to C, then back to B, then back to A. So it has to come back to the point where it originated from. Hence, it will be from A to B to C to B to A. That is one oscillation. So that is all for today's episode 1A of Physics O-Level. And the next video or the next episode will be about scalar, vector, and vector diagrams. Don't forget to subscribe, like, and share, as it helps the algorithm, especially because this is my first video as well. Thanks.